Okay, in this lab we're going to be actually determining the formula of a copper chloride hydrated sample. Now, by hydrated, what that actually does mean is it's going to organize a fixed number of water molecules around it. So that Z that's on this little page right here is going to be a whole number. Now, dihydrates, trihydrates, even up to hexahydrates with 6 are actually common for many ionic compounds. And really what this is almost like a desiccant. So if you had pure copper chloride, and it doesn't matter which copper chloride you have, they typically will absorb water from the air. They hydrate themselves. And they don't get wet per se, they will actually just get to be more of a crystal. The copper chloride we're going to see today is actually a brownish black substance, and as it hydrates it'll turn bluish green, and we'll be able to get a chance to see that. So what we're going to do in this lab is actually kind of neat. We're going to start with a sample, and we're going to get an accurate mass from the scales with that. And our very first thing we're going to do to that sample is actually cook the water off. So we will take our copper chloride hydrate and turn it into just copper chloride. Now, can't do anything with that number yet because that's actually useless. We need to actually get it down to the individual masses. So we're going to do another single replacement type reaction where we turn the copper chloride into copper and then chlorine ions. We're going to do that with aluminum. It turns out aluminum will do a single replacement reaction with that copper chloride. So we will put a piece of aluminum in with our copper chloride solution that we're going to make, and all the copper will precipitate out. Well, we'll be able to get an accurate weight of the copper then, and from that we will deduce what the chlorine weight is, and after that we'll deduce what the weight of the actual water is. Alright, let's cut to the lab and see how this all goes.